In 1736, the people of Königsberg had a problem. Not a war, not a plague, not even a particularly difficult math equation. No, they were obsessed with something far more important. Whether you could take a nice Sunday walk across all 7 bridges in their city without crossing any bridge twice. Spoiler alert, you can't. But proving why you can't? That accidentally invented an entire branch of mathematics. And the guy who did it? He was about to go blind, had 13 children, and somehow still found time to write more papers than you've written text messages. This is the story of how a walking problem in Prussia changed everything. All right, let's set the scene. Konigsberg, which is now called Kaliningrad because history is complicated, was this beautiful Prussian city built around the Pregel River. The river split the city into 4 parts, 2 riverbanks on either side and 2 islands chilling in the middle. And connecting these 4 pieces of land were 7 bridges. Just 7 bridges. That's it. That's the whole setup. Now here's where it gets good. Apparently, and I love this, the locals turned this into a recreational challenge. Like, people would genuinely spend their weekends trying to figure out, can I walk through the entire city, cross all 7 bridges exactly once, and end up back where I started? People tried, they failed, they tried again, they kept failing. They drew maps, they argued in taverns, they probably bet money on it. And here's the thing, nobody could prove it was impossible. They just knew it felt impossible. You know, like folding a fitted sheet, or eating just 1 potato chip, or understanding why anyone would voluntarily do calculus. But feelings aren't math. And in 1736, a mathematician named Leonard Euler, who, by the way, had way better things to do, heard about this little walking problem and thought, you know what? I'm going to end this debate. And he did, in the most mathematically disrespectful way possible. Before we get to the solution, you need to understand who Euler was, because this wasn't just any mathematician solving a puzzle. This was Leonard Euler, the man, the myth, the absolute machine. Born in Switzerland in 1707, Euler had one of those brains that just worked differently. He could calculate complex equations in his head faster than you can open the calculator app on your phone. He revolutionized calculus, number theory, graph theory, topology, physics, astronomy, music theory. Basically, if it had numbers, Euler owned it. Oh, and he did this while raising 13 children. 13! I can barely remember to water my plants. And here's the kicker. Around age 30, he started losing his vision. By his late 50s, he was almost completely blind. Did that stop him? No. He just dictated his work to his assistants and kept going. In fact, some historians say he became more productive after going blind. So yeah, when this guy heard about the bridge problem, Konigsberg never stood a chance. Now, here's where Euler does what every great mathematician does. He ignores the actual problem and solves a completely different one instead. Everyone else was physically trying to walk the bridges, drawing routes, getting confused, getting blisters, probably regretting their life choices. Euler looked at it and said, what if we don't care about the bridges at all? Stay with me. Euler realized that the size of the bridges didn't matter. The shape of the land didn't matter. Whether the bridges were made of stone or wood or hope and dreams didn't matter. The only thing that mattered was which pieces of land connect to which other pieces of land. So he did something radical, something that seems obvious now but was genuinely revolutionary at the time. He drew the 4 landmasses as dots, just dots, and he drew the 7 bridges as lines connecting those dots. Boom. He just invented what we now call a graph. And no, not the kind with an X and Y axis that gave you anxiety in high school. This is a completely different thing. A graph in mathematics is just dots connected by lines, nodes and edges. That's it. And suddenly, the bridge problem became a graph problem, which meant it became a solvable problem. This is like if someone asked you to untangle Christmas lights, and instead of actually untangling them, you just threw them away and bought new ones. Technically, you solved the problem by redefining what the problem is. Genius. All right, so now we've got our graph. 4 nodes, 7 edges. Euler asked himself, if you're going to walk a path that crosses every edge exactly once, what does that actually require? Think about it. Every time you arrive at a node, a piece of land, you have to leave it, right? You can't just stand there. That's not a path, that's loitering. And loitering is a completely different branch of mathematics. So if you enter a node on one edge and leave on another edge, that's 2 edges connected to that node. Enter, leave, enter, leave. Everything's paired up, which means for most nodes, you need an even number of edges. Now, there are exactly 2 exceptions to this rule. Your starting point, you leave but never return. Your ending point, you arrive but never leave. So here's Euler's big insight. For a path to exist where you cross every edge exactly once, you can have at most 2 nodes with an odd number of edges. Got it? At most 2 odd nodes. Now let's check Konigsberg. Node A, the north bank, 3 edges, odd. Node B, the south bank, 3 edges, odd. Node C, the east island, 5 edges, odd. Node D, the west island, 3 edges, odd. 4 nodes. All of them have an odd number of edges, which means it's impossible. Not hard, not tricky, not maybe if you start from the right spot. Mathematically, impossible. The people of Konigsberg were trying to do something that could never be done, and Euler proved it without taking a single step. He looked at a problem that had stumped an entire city, stripped it down to its bare mathematical bones, and said, yeah, no, can't be done. Here's why. Absolutely brutal. Now you might be thinking, okay, cool story, bro. Some people couldn't take a walk. Why should I care? Here's why. Euler didn't just solve a bridge problem. He accidentally created graph theory, one of the most important fields in all of mathematics. Let me show you how deep this goes. Graph theory is how Google Maps finds the fastest route to your destination. Every time you ask for directions, you're using Euler's insight. It's how your brain's neurons connect and communicate. Your thoughts, right now, are traveling along a graph. It's how Facebook and Instagram recommend friends. Social networks? Literally just graphs of people. It's how the internet itself is structured. Every website, every router, every connection, it's all nodes and edges. It's how airlines optimize flight routes, how delivery companies plan their schedules, how epidemiologists track disease spread. Every time you're on social media, playing a video game, using GPS, or literally doing anything on the internet, you're using graph theory. You're using Euler's insight that sometimes the specific details don't matter, only the connections do. And it all started because some people in Prussia couldn't figure out how to cross 7 bridges. That's the power of mathematics. You solve one useless puzzle, and 300 years later, it's running the entire digital world. And here's the thing about Euler. This wasn't a one-time genius moment. This was just Tuesday for him. Throughout his life, Euler had this almost supernatural ability to look at a messy, complicated problem and find the one simple pattern underneath it all. He did it with bridges. He did it with prime numbers. He did it with calculus, with physics, with music theory, with astronomy. The man wrote over 800 papers and books. 800. To put that in perspective, if you wrote one paper every single week, it would take you over 15 years to match him. And most of us can't even write a coherent email. And get this, he did a huge chunk of that work after he went blind. He just dictated his discoveries to his assistants like it was nothing. They'd read him problems, he'd solve them in his head, and they'd write down the answers. Euler didn't just solve problems. He invented entirely new ways of thinking about problems. He saw connections that no one else could see, patterns that were invisible to everyone but him. And that's what makes him one of the greatest mathematicians in history. So next time you use Google Maps and it tells you the optimal route, remember, you're benefiting from a 300-year-old solution to a walking problem in Prussia. Math isn't just abstract symbols on a chalkboard. It's the hidden structure of reality. And Euler? Euler could see that structure better than almost anyone in history. The Seven Bridges of Königsberg couldn't be crossed, but the path Euler created with his solution? We're still walking it today. If you want to see more stories like this, where impossible problems, blind mathematicians, and accidental genius collide, hit that subscribe button, because we're just getting started with Euler. And trust me, the bridges problem? That's one of his simpler achievements. Next time, we're talking about a number so important, so fundamental, that it shows up in everything from compound interest to the spiral of a nautilus shell to the way populations grow. A number that Euler himself helped define. I'll see you then.